Okay, hello everyone. So welcome back to my video, and today we are going to learn about one of the most fundamental concepts in calculus, limits and limits of function. Before we study derivatives and integrals, we must first understand the idea of a limit because it forms the foundation of almost every topic in calculus. So, what is a limit? A limit describes the value that a function approaches as the input, or the variable approaches a certain number. Notice that the word approach is very important. A limit does not always describe the value of the function exactly at that point. Instead, it tells us what happens to the function as we get closer and closer to that point. For example, imagine you are walking toward the door. Every step brings you closer to the door, but before touching it, you are only approaching it. This idea is similar to the concept of a limit. Now, let's define the limit of a function. Suppose we have a function f of x. We write the limit of f of x as x approach a is L. This means that when the value of x gets closer and closer to a, the value of the function gets closer and closer to L. It does not mean that fa is equal to L. Sometimes the function may not even be defined at x equal to a, but the limit can still exist. Let's look at a simple example. Consider the function fx is equal to 2 times x plus 1. What is the limit as x approaches 3? If we substitute numbers closer to 3, we obtain when x is equal to 2.9, so the function will be equal to 6.8. When x equal to 2.99, so the function is equal to 6.98. When x is equal to 3.01, so the function will equal to 7.02. When x is equal to 3.1, so the function is equal to 7.2. As we can see, the function values becomes closer and closer to 7. Therefore, the limit of fx as x approaches 3 is 7. For continuous functions like polynomials, finding the limit is usually very simple. We simply substitute the value of x into the function. Now let's discuss one-sided limits. There are two ways to approach a number. First, we can approach it from the left, which is called the left-hand limit. It is written as limit from fx as x approaches a from left. Second, we can approach it from the right, which is called the right-hand limit. It is right as like that. So, a limit exists only if both one-side limits exist and are equal. In other words, if the left-hand limit equals the right-hand limit, then the limit exists. However, if they are different, then the limit does not exist. For example, imagine a pseudo function. Suppose that for x less than 2, the function equals 3, and for x greater than or equal to 2, the function equals 5. If we approach 2 from the left, the function approaches 3. If we approach 2 from the right, the function approaches 5. Since 3 is not equal to 5, the limit at x equals 2 does not exist. Now, let's discuss an important relationship between limits and function values. Many students think that the limit and the function value are always the same. Actually, they are different concepts. The limit tells us what the value of function approach. The function value tells us the actual value of the function at that point. Sometimes they are equal, sometimes they are different. For example, suppose a function has a hole at x equal to 2. The graph approaches 5 from both sides, but the function is defined as 8 at x is equal to 2. In this case, the limit is 5, while the function value is 8, so the limit still exists even though the function value is different. Now, let's summarize the condition for a limit to exist. A limit exists if, first, the left hand limit exists. The second is the right hand limit exists, and then the last is both one side's limits are equal. So if one test condition is not satisfied, then the limit does not exist. Okay, I think that's enough for me. Understanding limit is essential because they provide the foundation for derivatives, continuity, and many other topics in calculus. Thank you for your attention and see you to the next video.